Now we welcome Professor Dr. Sajjad A. Ghauri will be speaking on modulation classification trends and challenges. Dr. Sajjad, I request you to share the screen and start your presentation.
Assalamu alaikum. I am visible, all of you.
Yes, sir. You are visible.
Okay, thank you. So we have a very limited time. So in this time, I will cover up some future trends about the modulation classification and some recent challenges, which maybe you. So the brief outline of my presentation is like that. First of all, I'm going to introduce some application area of the modulation classification, and then let us know what is the modulation classification and how many types broadly classified modulations, and then we are going to see the generalized system for the modulation classification, and then some future trends of the modulation classification. After that, I will go through some case study in which we are going to use the modulation classification by using voting-based deep convolutional neural networks. And at the end of this case study, I will show you some challenges which may be cut down for the future work. So for the limited time, I am skipping this one. This is my summary. So in the digital communication systems, the modulation classification is a very promising technology and technique, and the cognitive reduce is used to achieve the better spectrum utilization in the digital communication system due to some non-licensed users. There are very potential applications of the cognitive radio, and they are in the military as well as in the commercial application. So in this presentation, I am only restricted to the military application, so that we have no information about the enemy signal. And at the receiver end, we need to identify the modulation format of that signal. So for that one, the modulation format includes the type of the modulation, the alphabet size, the nominal carrier frequency, symbol constellation, and the frequency deviation for the frequency modulated signals only, as well as the symbol rate. So at the receiver end, we have to detect these non-licensed transmitters, and that should be done by recognizing the classifying the or recognizing the modulation format. So if I'm talking about the modulation classification types, there are two types of modulation. Two types from which modulation classification can be done, that is the manual and the automatic. In the manual modulation classification, the researchers use the modulator banks, and for each type of modulation classification, there is one modulator bank. So if we want to classify more than number of modulations, we have to require more modulation, which makes the overall process or implementation of that process very difficult. So for simplifying this problem, we are going to the non-optimal approach, that is the automatic modulation classification, and that is an active research area. In this, automatic modulation classification is employed at the receiver end, and this happens between the detection and the modulation of the signal. So if I'm talking about the broadly classification of automatic modulation classification, there are two types of modulation classification. The first one is the decision static approach, in which we are going to extract the likelihood function from the received signal. This likelihood function may go through some hypothetical tests, and these hypothetical tests are average likelihood ratio test, generalized likelihood ratio test, and many more. And these tests are optimal solution, but they are very complex. So we have to move forward towards the pattern recognition approach, and this is also known as feature-based approach. In this approach, we are going to extract the information, relevant information, distinct information from the received signal, which was corrupted by the noise and as well as some fading effects. So these features are going to be extracted from the received signal, and after that, these signals are fed into the recognizer structure. This recognizer subsystem have sorry, slides are stuck. Okay, Okay, so in the pattern recognition system, this approach we are going to use the classifier. Classifier is basically there are different types of classifiers which we are going to discuss later. But this approach is widely used, but it is suboptimal approach. So if we see the generalized system model, this is a generalized system model for the pattern recognition approach. So this is the whole transmitter and receiver side. If we see from the input symbols, these input symbols are fed into the modulator. The modulator is basically of different types. For example, we are going to modulate the signal by using pulse amplitude modulation, quadrature amplitude modulation, phase shift keying, or frequency shift keying. There are different types of modulation which we have employed in this one. After the modulation, the signal is passed through the different effects of that fading as well as the channel noise. And at the receiver side, we are first going to pre-process that signal by removing the unwanted noise and some different techniques we are going to use in the pre-processing. After that, the major step is the extraction of features. So in the literature, there are many authors have used different type of features. For example, higher order cumulants, spectral features, keyboard features, transform-based features, cyclic features. So after the extraction of this valuable information from the received signal, these features are fed into the classifier structure. Right now, they are using some deep neural networks, machine learning, different types of algorithms, the different type of filter network, which is the keyboard filter network, and some stochastic models, which is the hidden Markov model as well. And at the end of the day, we are able to classify the signal at the receiver end. So this is a generalized overview picture, pictorial view of the modulation classification. So from this, we are able to see some future trends. We can use deep learning advancements. These advancements are in the deep learning networks such as convolutional neural networks and recursive neural networks, and some different type of transformers by LSTM. These type of approaches we can use for the modulation classification. We can also use the hybrid approaches, which is the integration of the machine learning algorithm with some traditional signal processing techniques which we have employed earlier. Some adaptive algorithm can be used to adjust the different channel condition. For example, we are going to real-time implementation of these type of algorithms. We can also employ these algorithms which may be robust to the noise, fading, other impairment. These are crucial for reliable communication in challenging environments. So that is the enhanced robustness. We can also use the modulation classification algorithms for the security and privacy. These are used for designing that accurately classify while preserving the original data privacy and security. So there are some specific solutions tailoring some specific solution in the satellite communication and as well as in the industrial IoT, and not last but the least, but that is AI-driven automation, which when used supervised and generalized AI-based models. So for the case study, we have used the voting-based deep convolutional neural networks. So in this system model, you can see we have a modulator with the channel, some sort of channel we are using. I am going to discuss these channel, that is the relay, Russian, and different type of channel. And we have the output of the channel is we are going to the signal segmentation. The segmentation of signal is given in the following equation, which shows us how we are going to segment the signal. And the segments of these signals are going to the different layers of the convolution neural networks, in which we have seen we have 25 layers, and then we have a fully connected layer, and then we have a softmax layer. After the output of each layer, the voting based fusion have been done, and this will tell us the modulation format of the received signal. So in this specific contribution, we are going to propose the modulation classification technique, which doesn't need any prior information of the symbol rate or baud rate. There is a reduction in the execution requirement of testing frameworks, so means we have a low computation complexity, and we are going to utilize the complete input signal bus to increase the classification accuracy. So that is the pictorial view of the proposed deep convolution neural network layers, in which we have seen we have an input layer which has 2 cross 1 204. Then we have 5 different layers of the CNN. You have seen that CNN1. Then we have a RALO unit. Then we have a max pool layer. Then the same process has been continued until unless we have the average pooling layer and the fully connected layer. So the output of these layer will give me the modulation types, and output of one column will give me one decision. The second column will give the another decision, and these decisions are going to be average out, and this will tell us the modulation format of the received signal. So if we discuss the computation complexity of my proposed voting-based deep convolution neural network, the total computation complexity is 736 computation we have to perform. If we see the specifically for the layer 1, we have 32 computations, and for the next full layer we have a 32 combinations. So we have total computations are 64, and these computations are in the layer 3 they are going to be multiplied by 2, and the similarly pattern has been followed in the layer 5. So total number of computation is 736 to perform the modulation classification. These are the simulation parameters which I have employed for this one, and these are very generalized and specific parameters which different authors and researchers have been utilized. So we are taking the samples per frame are the 10,000 and with different SNRs of 0, 5 and 10 dB. Due to shortage of time, I am not able to show you all the evaluation parameters on all the SNRs. So we have different architecture of the layer. We have considered only three types of modulation, which is PSK, FSK, and QAM, and the total number of epochs are and the number of iteration are approximately 25K. So for evaluate the performance of proposed classifier, so we have divided the simulation scenarios into three cases. The first case we are going to classify only NPSK and FSK signals jointly. Then we have only NQAM signals, and then the last case we have 9 different modulation formats, which is a combination of FSK, PSK, and QAM signals. So in the case 1, we have seen this is the performance classification at 10 dB of SNR, and from this confusion matrix we are able to see that our classifier performs 100% classification with 100% classification accuracy and accurately classify all the modulation formats. So the 100% classification accuracy is here due to we have used the very high SNR, which is 10 dB. So if we use some different channel conditions and low SNRs, the results may vary. Similarly, for the case 2, we have the classification accuracy at 10 dB of SNR, and we see that we have approximately 99% of accuracy for 16 QAM and 256 QAM, which we are higher order QAMs, and for the 4 QAM and 8 QAM, the accuracy is approximately 100%. Similarly, for 9 different modulation formats and 10 dB of SNR, we have seen that we have only classification accuracy difference of every 256 QAM and 16 QAM. So there are misclassification. Otherwise, all the classifiers perform very well. So in this whole scenario, we are testing the classifier for at specific 10 dB of SNR. Okay, if we consider different layer and channel conditions, so we can see if we are using a different number of layers. For example, at here we are using only 12 layers on the CNN architecture instead of taking 25 layers, 28 layers. So we have the accuracy of 90% for the test training, and for the testing we have less than 90% accuracy. Similarly, if we increase the number of layers and as well as the SNR, so the accuracy is increasing from 90 to 95%, and for the all 28 layers we have 100% accuracy. So there is a trade-off. If we have a low computation complexity, the accuracy is less, but we have little bit high computation complexity. For example, 736 computations, the accuracy is approximately 100%. So this is the performance of the classifier for different channel conditions. As we see that if we are only considering the AWGN noise and we are not considering the Russian and relay channel, the accuracy is approximately 80%, while for the AWGN channel accuracy is 100% approximately. So for significance at low SNR, the classifier performance is not very good. Almost all modulations are not classified accurately, but at least if we see that for the 16 QAM we have only 45% accuracy, for 257 we have 40% accuracy, and for the 256 QAM we have only 22% of accuracy. So this misclassification can be tackled in the future challenges. That may be that we can construct or simulate such type of model which can handle the dynamic and complex signals in Modern communication systems are dynamic and complex, making them challenging to classify. So these factors, multi-path propagation, interference, we have to use for the low complexity. Similarly, the deep neural networks require training, large amount of training data. However, in this case, we have only 10,000 samples per frame, so that is also a challenging task for the DNN to do use the limited training data and give the accuracy of 100% or maximum accuracy. For the real-time processing in many applications, modulation classification need to be very fast. Means we have received a signal, and within seconds we have to know what is the type of the modulation formula. So these all the challenging condition in the real time world that may be cater for the future work to make the classification accuracy better and to make the classification algorithm very simple. Thank you very much. Any questions?
Thank you, sir. Thank you for inspiring talk at this event. Your insights were truly valuable and left a lasting impression on all of us. We appreciate your time and expertise. Thank you so much for joining us. Is there any questions for sir? You can please ask. Thank you so much, sir, for your participation and your time. Um, Thank you so much.